In the last video, we took a look at an event which either could happen or might not happen. That is, whether we have more than 300 customers. This is an example of something called a binomial random variable. This occurs when we have an event that happens with some given probability, and therefore doesn't happen with probability given by subtracting that from 1. Right? So I just called it Q here. Right? So for example, the event that we have more than 300 customers is an event with probability 45%, and that event doesn't happen with probability 55% or 0.55. One of the things to be aware of is binomial random variables can happen. We can have the event experiment, we could have an outcome multiple times. We call those trials. So think of flipping a coin. That's the original example. A fair coin, you'll get heads 50% of the times, tails 50% of the times. So one trial, one flip. 50 trials, 50 flips, and you expect about half to be heads and half to be tails. Let's pursue this example where we have more than 300, regarding wanting to have more than 300 customers. And suppose that's because 300 customers is our break-even point. So we want to get 300 customers every week. So here's our probability for week 1. Less than 300, 55%, at least 300, 45%. Nothing surprising. I haven't told you anything new. Well, let's make 2 trials. So we'll look at 2 different weeks. So there are 4 possibilities here. The first possibility is that we have less than 300 customers in both weeks. The next possibility, less than 300 in 1 week, at least 300 in the second week. Vice versa for the third possibility, and for the last possibility, we have at least 300 for both weeks. So how do we get these probabilities? Well, I've added in a little assumption that we'll talk about a lot more later in this chapter. And that's, I'm assuming that these are independent trials. Let's go back to the head flipping examples. If you flip a coin and get a head, that's not, whether you got a head on the first coin or a tail flip or a tail on the first flip, isn't going to impact the probability of what you're going to get on the second flip. It's still 50% heads, 50% tails. We are assuming that's the case in this example, that the probability of having more than or less than 300 customers in 1 week is independent of the next week. Now, there are reasons to maybe push back against that assumption. For example, if you have a bunch of customers the first week but things don't go well, they may go back and tell their friends, and their friends may not necessarily be willing to come, and you'll have fewer customers the following week. Or if you do a great job, they'll go back and tell your friends, and you'll have even more, right? So there's reasons to not believe they're independent. But in order to model this, we have to make assumptions, and so this is the assumption we're making. So that assumption, what that assumption allows us to do is multiply the 2 probabilities to get the probability that both events happen. So if the probability in any given week that we have less than 300 customers is 0.55, then the probability that we have less than 300 customers in both week 1 and week 2 is 0.55 times 0.55, giving us 0.3025, or 30.25%. The probability that we have fewer than 300 in week 1, but at least 300 in week 2, well, the probability for week 1 is 55%, probability for week 2 is 45%. Multiply those together as decimals, and we get 0.2475, which is 24.75%. Now notice for the next outcome, we have at least 300 in the first week and less than 300 in the second week. So in some sense, it's the opposite of the previous outcome, but the number comes out the same. And the reason for that is because we can multiply in either order. And finally, the probability we get at least 300 in both weeks is 0.45 times 0.45, which is 0.2025, or 20.25%. Let's look a little bit closer at the 2 middle probabilities. Maybe we don't care which week has fewer than 300 and which week has at least 300, just the fact that 1 week is one way and the other week is the other way. Well, that means we have to add the middle 2 probabilities together, and since they're equal, that's the same as taking one of them and multiplying by 2. So here's what that looks like. The event that we have fewer than 300 customers in both weeks is now 0.55 times 0.55, or 30.25%. Less than 30 in one week and at least 300, sorry, less than 300 in one week and at least 300 the other week. Well, we don't care which week is which, but there's two possibilities, so it's 2 times 0.45 times 0.55, so 49.5%. And at least 300 both weeks. That's 0.45 times 0.45, which is 20.25%. Notice we are actually changing the nature of the random variable. We are now asking the question of how many weeks will we have at least 300 customers. This is still a binomial random variable. We're just asking how often the event that we'll call a success occurs. And if a success is flipping a tail, we could ask the same question. How many tails do we get in 21 tosses? And that's also a binomial random variable. So now with this random variable, let's take a look at what happens if we go over 3 weeks. And rather than going through all those calculations, let's just take a look at Excel. I've put all the results into Excel myself. So in this Excel file, in this Excel sheet, we've got the number of weeks with at least 300 customers over a 3-week span, and the probability of each of those events. So first we have 0. Right? We have less than 300 customers every single week over 3 weeks. That's about 16.6%. Having 1 is about 40.8%. 1 week with more than 300 customers. 2 weeks with more than 300 customers is about 33.4% probability. And having at least 300 customers all 3 weeks is about 9.1%. Keep in mind that if 300 per week is our break-even point, it's not looking terribly good. Here's the graph. It might look to you like there's a slight skew. But what's actually happening is these probabilities are getting more and more symmetric. Let's see how this works by extending this to 52 weeks, a full year. Here's the probability distribution for the number of weeks with at least 300 customers over a course of a full year, based on the assumption that each week independently has a probability of having at least 300 customers of 45%. So we can see all the numbers to the left, but the graph tells a much larger story. First of all, if we need to have 300 customers or more every single week in order for this to work, in order for us to break even, then we're in really rough shape. Although thankfully, if all we're doing is averaging, then you could probably figure out, you're probably in a little bit better shape, and that would be a more involved problem. But the point I want to make here is look at what's happened. This probability, now that we've got 52 weeks, 52 trials, looks much more symmetric. And that's what happens. The more trials you have, the more symmetric the distribution becomes. In the next video, we're going to talk more about what that symmetry means and how we can make our computations a little bit easier.